Line segment AC has endpoints A at -1 and -3.5 and C at 5, -1. Point B is on line segment AC and is located at point 2, -3. What is the ratio of AB to AC? So you can kind of draw this out in order to help. It's not necessarily needed to draw it out, but seeing a visual is sometimes pretty helpful. So -1 and -3.5 would be about right here. And then 5, 1 be about right here. And 0.2 and -3 would be about right here. And this is kind of our line. Can't get the point to show there. There we go, I got it. So what we want to do, if we want to make this ratio, then we need to just basically find, this is A, B, and then C, and we need to find the length of AB and the length of BC, and just create that into a ratio. So to find the distance of AB, since it's a slanted line, we need to use the distance formula. Remember that this is a formula that you definitely will have to have memorized. If you don't use it, I would be very highly surprised. So x of 2 minus x of 1 squared plus y of 2 minus y of 1 squared. Now we're going to go ahead and just plug in our values. A, the point is the -1 and -3.5. I'll go ahead and let this be my x of 1, y of 1, and this will be my x of 2, y of 2. So if we plug this in, our x of 2 is a 0.2, so we have 0.2 minus, and then a -1 squared, plus y of 2 is a -3 minus, and our y of 1 is a -3.5 squared. When we simplify this, you would plus, because you want to add that, and so that does give you 1.2 squared plus, this ends up being addition because of the double negative, so -3 plus 3.5 gives you 0.5 squared. Then you can use Desmos in order to help also. This is the actual question on here. If we wanted to do this, you could do 1.2 squared and then plus your 0.5 squared. You should get 1.69. Then if we take the square root of that, which you could just put all of this in parentheses and just put a square root sign in front, or you could rewrite everything too. Either way would be okay. The toolbar disappeared for me. Here it is again. And now I can see the square root sign. That's what we were looking for. So let me put the cursor back in front, and if we do the square root, it did not put everything inside like I thought, so it might just be easier to write it out separate. So it was 1.69. So the square root of 1.69 is 1.3. So far we have 1.3 for our length for AB. Now let's go ahead and find AC. BC. So I'm going to go ahead and let, for BC, I'm going to still let that be the x of 2, y of 2, but this time let's let this be x of 1, y of 1, and I'll do it in red up here. So BC is equal to, our x of 2 is a 0.2, minus x of 1 now is a 5, y of 2 is a -3, and our y of 1, so minus, and then we have a -1 squared. We simplify. 0.2 minus 5 would be a -4.8. plus, remember we have a double negative here, so it's really negative 3 plus 1, so we have a negative 2 here, squared. So 4.8, negative 4.8, if you want to put that into the calculator, you can do that to see what it's equal to squared. So 4.8 squared, and then plus, and we also had a negative 2 squared. Notice I dropped the negative because if we're squaring it, a negative times a negative is just going to cancel out anyways, but you could put parentheses. If you want to include the negative, you could put parentheses around each one of these, and just make sure that the negative is inside the parenthesis with it also. That way it recognizes that is also part of what you're squaring. So you could do negatives, but if so, it has to be inside the parentheses with it, and your exponent should be on the outside if you want to write the negative in here, and that way it figures out what it is properly. So we get 27.04. And once you get the 27.04, you have to also take the square root of that. So for our next step, we will take this 27.04, take the square root, which gives you 5.2. So that means that our length of BC is equal to 5.2. So our final answer could be 1.3 over 5.2. You could see if you can simplify it anymore. When glancing at the answer key, it does say, though, that any equivalent fraction would work, or you could even put it as a decimal. If you reduce these, they're both divisible by 13, or 1.3. And so if you divide by 1.3 for each of these, you would have 1 over 4. Or if you just divide your decimals, you would also have 0.25. All three of these would be acceptable answers for this problem. If you have any questions, please let me know.